When we're creating a system of component models, like the modular approach, it's necessary for these components to have a common interface. Now, with finite elements, this is quite simple. You can actually literally connect the dots. However, with a measurement, there's no really such a thing as a node. You cannot actually measure the exact point that you would like to measure. In addition to that, you would like to include both translations and rotations in your measurement because this benefits the higher frequencies.
In order to measure the dynamics of this structure in the coupling point, we position a virtual point in the center. Then we have sensors that we put around this virtual point and that we can position freely. Next to that, position impact points where we excite with a hammer around the structure. Then the virtual point transformation will ensure that all the measured dynamics are transformed into this point, such that we obtain the translations and the rotations of this structure in this virtual node. The virtual point assumes that the structure around this coupling point behaves rigidly. That means that the motion of the sensors give access to the translational and the rotational behavior in this very point. Now that we have this virtual point dynamics, we can evaluate if the sensors behave consistently, if all the hammer impacts match up, and if we didn't make any bookkeeping errors during the measurement. Next to that, now that we have the virtual node description, we can actually evaluate the reciprocity of the system as well as the passivity, things that are crucial if you later on want to couple your system using dynamic substructuring.